Hello everyone, welcome back to my YouTube channel. This video, I'm going to show you the last part for my Form 4 SPM Form 4 Physics Chapter 4. I'm going to show you on the gas law, and just before we get into the gas law, I would like to give you a quick look on this is Form 4 Chapter 4, the last part, where the gas law. So what we will learn in this last part is a very basic, very simple thing, comprises of P, V, a general equation that we'll learn sometimes later, where they have equals to nRT, small n RT. I know that the first two terms is not mentioned in your reference text because in Form 5 SPM, this is actually a constant number. It doesn't need to worry. All you need to know would be P means pressure. In BM by now, I think you call it as tekanan. I think you have covered this in my chapter 3, pressure, force over area. You get to use it here, where V is volume, and T would be temperature in Kelvin. So in short, not to say you ignore, but at least you know it's PVT. These are the three quantity that you need. Now why is that so? I will call it a constant because all these three quantity is very much governed by, says, a volume. No, let me have a cube. In this equation, or in SPM physics, you have a system, isolated system, where you have a fixed amount of molecule. The amount of molecule, or the mass, or amount of atom, okay? Because atom, millions, trillions of this atom moving around at room temperature. You bombard with a wall, side wall, and bounce back, up and down, left and right, collide with each other, like what I've mentioned in the kinetic gas theory, right? So what happened to kinetic gas of theory, it says, oh no, before we go to that, that's the reason to why mole, the mass is the same. This is a constant number, so it doesn't need to take care of it. So therefore, this equation will always be PV equivalent, will be direct proportional to T. Okay, these are the three quantities that you need to learn, and you need to make use of it. Now, how is that so? At room temperature, when the temperature increase over this scenario, over here, okay, when you heat it up, you heat up this cube of atom, the temperature increases. What happened to the temperature increase? As you have learned you have seen from my previous video, the average, the keyword, the average kinetic energy increase. Average kinetic energy of the gas increase. You provide heat, temperature increase, meaning you provide heat. The average kinetic energy of gas increase. What happened to kinetic energy of gas increase? It moves faster. Those particles move faster. When you move faster, you will collide. Like what you have learned in previous chapter, you collide with each other as well as with the wall and with each other. So what happened? What happened is move faster, collide with each other at higher frequency. Higher frequency meaning more frequent. Okay, provide heat, average kinetic energy increase. The particle move faster, you collide with the wall as with each other. Therefore, the frequency of collision is higher, and therefore the change. This is important word, change of momentum also increase. Now, where you learn this change of momentum, you learn in chapter 2. Okay, kindly refer to my chapter 2 video to my YouTube channel, where over there we cover the change of momentum is actually equivalent to the force. Okay, d over dt, change of the momentum, mv, mass and velocity. Where we have example, there is a ball bounce back to the wall is 2 mv, right? Where you have wall, your atom m bounce back, the change in momentum, small change of momentum is p, is actually equivalent to negative 2 mv, isn't it? Okay, this is what you have learned in chapter 2. Why is it negative? Negative is just a direction. Okay, if you were to define positive to the left, so first of all, this is positive mv because I define positive to the left. So positive. So what happened? Bounce back, opposite direction to what defined, negative mv. The mass is the same. We assume it's direct collision, no loss in the velocity. So therefore, any change in momentum will always be the final minus initial. Therefore, you get this negative 2 mv. So I explain it here. You doesn't need to go through, look for my video. I hope it saves your time. So this is what will happen, and this is what is stated there. And it's also the first thing you could learn from this equation, because when the temperature increase, the pressure increase too. Therefore, the pressure of the gas increase with its temperature. It's direct proportional to T for the same amount of volume, because here V is missing. So the first equation, how you relate them is, you relate P and T. So P is direct proportional to T. When P increases, T increases too. Okay, so who found this? The founder his name, and they call this as a Boyle's law. Okay? In Boyle's law says the pressure of a fixed mass of gas. Oh, sorry, PT is the other one. PT is pressure law. Okay? No, we're going to go to P and T first. How can it be P and T? The Boyle's law, guess its name, first interact with P and V. So P and V, you get a constant. P and V, over here, you get a constant. P and V is a constant. Okay? So therefore, P is that proportional to 1 over V, because K, when you are direct proportional with a constant K, right? So when the P of a pressure of a fixed mass inverse proportional to its volume, P inverse to its volume, when P inverse volume is Boyle's law, right? Where P, V, the product has to be constant, a fixed number. So you bring it down, therefore 1 over V, right? How can I relate this law to this theory? Now, what happened for this cube when the volume increase? When the volume increase, according to this is a theory of kinetic gas, kinetic theory of gas. This is kinetic theory of gas. From this kinetic theory of gas, how do we explain Boyle's law? When the volume increase, the mass remain, right? Correct. Here, if you have 100 particle, if you put it into a bigger container, you will still have 100 particles. So, what happened when volume increase? What happened? The frequency of collision reduces. Therefore, the change of momentum reduces, and therefore the force reduces. And the force reduces, therefore the pressure also reduces, because pressure is equivalent to force per unit area. When the force decrease, pressure decrease. This is you have learned in also chapter 2 or chapter 3 from 4. Okay, so to put it in a graphical form, graphical method, so that it helps you to remember. One way is to use this cube, volume increase, collision reduce, momentum change reduce. Another way, how to measure it? Put it in a piston. This piston is connected to a device. What's the device used to measure the change in pressure? Tick tock. You have learned it, right? In the previous day. I hope you have read through the your reference text as I wanted you to do so. Recall bottom gauge, right? In pressure. So what happens if you press on this piston over here? The volume reduces. When you press into here, the remaining volume reduces, and therefore the volume reduces, pressure increases. Pressure increases in Pascal, bottom gauge. Okay, so that's how this theory is about. And to put them into equation, so therefore you bring it up, what happened? P1 V1 it will be equals to pressure number 2 V2. Please do not really memorize it, because I think it's given in your exam sheet, but you just need to understand. But the moment you understand it, eventually this equation will come out. P1 V1 equals P2 V2. This is called Boyle's law. Okay? Same system initially maybe it's by this volume, this pressure. Next moment you squeeze it smaller, I mean the pressure, your volume reduce it, they will ask you what is the pressure. That's all about. Always the same thing, or maybe always the same piston. Okay, so all you need to do is rearrange them. Maybe something about how do you rearrange? Simple, like this. Put it in additional maths. Let's. I think I'll cover a few chapter. I mean, cover all the additional maths chapter. So if you want to look for what is V1, therefore V1 will be equals to P2 V2 over divided by P1. Pressure Pascal, volume will be meter cube. Then you're able to find what's V1, what's the initial. 1 is initial, V is final. So this is initial meaning beginning. You need to learn those words already. Final is V2. The 2 is final. You have 2, it means final. 1 meaning initial. Okay, so the initial volume is this. They will give you a parameter. Okay, the final pressure, the final volume, and the final pressure. I mean the initial pressure. What's the initial volume? Or the other way around, or the other quantity. Yeah. So be sure you know how to look for volume. If it's a cube, then you times on the side. If it's a cylinder, then you get the pi r squared times height. Okay, so that's all about it. You may go through the text reference textbook on how to get this. It's very simple, straightforward. Read on the experiment. Yeah, it comes out in paper 3. Learn up the experiment. What are the apparatus? You need to sketch it on a piece of A4 paper. That's always no such thing called simple shortcut. You need to learn it. Okay. Sometimes pressure could be expressed in centimeter Hegelian, centimeter Mercury. Okay. It depends on question. It will let you know about it. Okay. So you just need to stop this video, pause this video, go through those exercises relates to Boyle's law. You must have at least 8 to 10 questions, objective question, multiple question, multiple choice, and practice on this part, Boyle's law. Yeah, you really need to do so. The pressure could be Pascal, the pressure could be in centimeter Mercury, and when this open space, be sure you include the atmospheric pressure, which is 76 centimeter Mercury. If a closed system, then no need. Okay, because the pressure is always from the amount of mass above it who press onto it, right? It's always the case. Amount of mass above who press onto it. That's what we have gone through in the past. Okay, so next, second law. Just like in chapter 3, 3 law, chapter 4, also 3 law. Okay. Second law, one's Boyle's law, pressure law. In pressure law, so the first one, you deal with PV. Pressure law, you deal with PT. So first one, PV, is called Boyle's law. Second law, PT. Okay, where pressure law, P, therefore, will be direct proportional to T, according to your kinetic theory of gas. Again, the same diagram. Okay, so meaning when temperature increase, the pressure increase. This is how I started off to explain this theory of kinetic gas. When the pressure increase, temperature increase. Okay, a pressure of a fixed mass of gas over here, fixed mass of gas, is direct proportional to its absolute temperature in Kelvin. Okay, this is how it works. So over here, how do you use it? Put in the equation. So the equation would be P1. So always a constant here. So bring it down T. So P1 over T1 is equals to P2 over T2. Okay. If it doesn't already know, learn it now. Okay. T, bring it down, P1, T1 equals to P2, T2. 1 will always the initial, 2 is the changes. Okay? It happen all the time. Okay? Then you increase, you need to read on the experiment. What's the experiment to conduct this? Okay? Important, you need to refer your reference, your text, book or reference on the experiment. Not only for this law, the Boyle's law, the pressure law as well. Okay? Where you have a bulk of air, you heat it up in the water so that the water maintain the equivalent heating. Then there is also a bottom gauge to measure pressure. Okay? And a note here is that I think I covered it earlier. Degree C degree. Okay, it's two different things. Degree Celsius, meaning this is the degree of hotness. Celsius degree means the change, meaning there's a change of temperature. This is what you have learned previously. I won't bring it up here again, right? So pressure law, and the last one, I think it's quite pretty straightforward. Okay, you have P and V, P and T. The last one will be V and T. Okay, so the last one, the last law, they call it third one, the last one, the Chap's law. Okay, P and V, P and T. Now we have V direct proportional to T. It's always constant. You just need to know it. Volume of a fixed mass direct proportional to its absolute temperature in Kelvin. Okay, absolute temperature in Kelvin. Okay, put into equation. So therefore, V1 over T1, V2 over T2. Okay, that's all about it. Okay, in every law, you need to pause this video, look for those exercises, 8 to 10 questions. You follow my way of doing, you will not get it wrong. So this one, temperature in Kelvin. Always remember, okay? Paper 3 and paper 2, sometimes they catch you on this. Don't get caught. I hope you won't get caught. Because in experiment wise, you need to learn how to sketch the graph as well. Okay? How's a graph for Boyle's law? Those graphs for Boyle's law is important. By looking at it, you will know, oh, in objective question, yeah. Okay, Boyle's law. How the graph should look like? You have P inverse proportional to V. So how the graph should look like? There are a few ways it should look like in maths. Okay, if it were to be P versus 1 over V, then therefore it will always be direct proportional, straight line. No doubt. What happened? Yeah, this graph will normally come in paper 2, if I'm not mistaken. P, V. How the graph should it look like? Inverse proportional, inverse, right? So inverse, therefore, will be inverse. Okay. Be sure you know the unit, Pascal or Pascal and meter cube. PV is always constant, right? Then next you have pressure law. Pressure law you have P direct proportional to T. This is rather straightforward because direct proportional won't be too hard, because this is where you learn the 273 degree, the absolute temperature. Okay, you look at the example from your reference text, how to solve those problems. I think by now you are pretty good at it already. So this one, pressure law, I think it did come out in one of the past year. I think it's kind of like a bonus question because Pascal, okay, normally be sure you need 0 and also your degree temperature. If it were to be Celsius, be careful. If it was Celsius, therefore you have a straight line here. Celsius, you have a straight line here. Extrapolate this line. This number should be -273. This is the tricky part. Okay, important thing is you look at what's the unit here. If it were to be Celsius, then be sure you extrapolate it. Else they'll give you the same thing here. Pressure, Pascal, same axis, temperature. Instead of Kelvin, instead of Celsius, they give Kelvin. So when it's Kelvin, therefore it will be direct proportional because absolute temperature. Okay, this will normally comes out, okay, in your final, in your, well, where else it comes out? Okay, pressure law. The third one, Charles' law. Maybe I'll do it here. Charles' law, V over T. So therefore, the graph, you don't confuse because they look very similar, because this is also Kelvin, absolute temperature. Again, they are the same. The form look like the same. It's just that now it's volume. Okay, volume maybe in centimeter or meter cube. Depends on question. Sometimes meter, sometimes centimeter. You need to look at it carefully. Be sure you label your 0. And this is temperature. Look at what they gave you. If the question give you, says degree C, maybe degree C. So no doubt, straight line, extrapolate. Cut at -273. Okay? Alright. When it were to be the same axis given to you, they want to test you if you know it. It is absolute temperature. Maybe they start to use a symbol like this so that you frighten you a little bit more. Kelvin. So it will be Kelvin. What happened? It will be 0. It will be direct proportional, right? Here, direct proportional. The same goes here, direct proportional. Okay. So this chapter, this part is always comes out in your objective, paper 2 and paper 3, always the case. So all you need to do is you go back, at your time, go through a reference, look for the application. How do you apply this 3 law? Okay? The Boyle's law will always be the bicycle pump, the famous. Look for it, how does it work? Okay? Initial and final, when you press down, what is it? Right? Tire will be pressure law. This is what you happen in tire. Pressure increase, temperature increase, pressure increase. Charles' law, hot air balloon. And there are a few more, of course. It's not limited to here. All you need to do is you really need to go through your reference. Go through the text. Okay? These are the essence. You learn it from a video. Go through the exercise. This chapter, for this part only, after watching this video, you should have completed at least 30 questions, objective questions by yourself, calculation, and get it right. Okay? That's all from me this time round. I hope you press on the thumbs up button, subscribe to my video, subscribe to my YouTube channel. I will have more video on SPM for you to help you out when you're at home. You will miss out certain things. But no matter how, you still need to sit down and do the exercise. Each video commitment, 30 objective questions. In addition to extra like say paper 2, paper 3 in the past year. That's all from me. Stay tuned to my next video. Thank you.